Section 1. The New Gold Rush. Imagine looking up at the night sky, and not just seeing distant stars but seeing a vast, untapped resource waiting for us. That's the promise of space mining. In simple terms, space mining is the act of harvesting valuable materials from celestial bodies. Asteroids. The moon. Other planets. It sounds like a scene ripped straight from a science fiction movie. But this is a future that scientists, engineers, and entrepreneurs are actively working toward today, right now. The technology is advancing, the plans are being drawn, the motivation is growing stronger every year. This isn't just about exploration, it's about building a sustainable future for humanity, on Earth and beyond. Why should we care? Earth has limits. We rely on a finite supply of metals, minerals, and other resources to build everything from our smartphones to our skyscrapers. Section 2. A celestial treasure chest. So, what valuable resources are we actually looking for out there in the cold, dark void of space? The targets are diverse, each holds a different kind of treasure. The most talked about candidates are near-Earth asteroids, giant, floating rocks, rich in materials. Some are C-type, containing water in the form of ice. Water is the single most valuable resource in space. Astronauts can drink it to survive, and it can be split into hydrogen and oxygen. Together they form powerful, efficient rocket fuel. Beyond water, M-type asteroids are like flying mountains of metal, iron, nickel, and cobalt, core ingredients for steel and infrastructure. S-type targets can harbor platinum group metals, rare on Earth but essential for catalytic converters and advanced electronics. A single small platinum-rich asteroid could contain more of these metals than have ever been mined in human history. The moon is another prime target in our cosmic backyard. Lunar regolith is rich in oxygen, chemically bound to silicon and metals. If we can extract it efficiently, that oxygen supports breathable air in habitats and serves as oxidizer for rocket propellant. The moon likely holds aluminum and titanium, ideal for in-space manufacturing and construction. Ice in permanently shadowed craters could provide water, air, and fuel, crucial for a sustainable, long-term lunar presence. Section 3. The Interstellar Pickaxe. Extracting resources millions of miles away from Earth requires a whole new kind of toolkit. The process will be almost entirely robotic, relying on autonomous machines built for harsh space. First, identification and prospecting. Telescopes on Earth and in orbit spot promising asteroids. A fast scout spacecraft surveys up close, mapping the richest deposits of water and metals. Detailed surveys guide the main operation to the most profitable, accessible location. One concept engulfs a small asteroid in a large bag for on-site processing, or nudges it into a stable orbit around the moon for easier access. For larger bodies, surface miners, crawlers, drills, scoops, and cutting tools excavate regolith or break rock like precision cosmic bulldozers. Humans supervise from Earth, but autonomy handles the time delays. Water extraction, heat icy soil in a closed chamber, capture vapor, condense it back into liquid water. Metals, melt regolith around 1600 degrees Celsius and run current through it, separating oxygen gas and collectible liquid metals. In-space manufacturing, additive printing, turns feedstock into tools, spare parts, even habitat structures, enabling in-situ resource utilization and a self-sustaining build cycle. The potential benefits of successfully mining space are enormous and could ripple through our civilization in profound ways. The most immediate impact is on exploration. Launches are costly largely due to the fuel needed to escape Earth's gravity. By producing propellant from water ice on the moon and asteroids, we can create orbital gas stations. Rockets can launch lighter, refuel at depots, and continue farther, dramatically lowering cost and boosting capability. Back on Earth, sourcing high-demand materials from lifeless asteroids can ease environmental strain, secure tech supply chains, and help preserve ecosystems. A robust space economy spurs new industries and high-tech jobs. Robotic engineers, asteroid geologists, orbital mechanics experts, resource managers. Breakthroughs in robotics, artificial intelligence, materials science, and propulsion will cascade into many sectors, like Apollo did for computing, communications, and medicine. To build lasting settlements, we can't ship every nail, brick, or drop of water. It's not feasible or sustainable. Pioneers must live off the land, use local materials to build, produce air and water, and manufacture tools. Asteroid and lunar resources provide the raw inputs. space mining isn't just about bringing value back, it's about taking the next great leap and establishing a lasting human foothold among the stars. While the promise of space mining is dazzling, the path is filled with monumental challenges. First is cost. Research, development, and deployment of sophisticated robotic fleets will require billions, if not trillions, up front. Each mission is high risk with delayed returns, making early-stage funding difficult. Technology must be proven. Space brings extreme temperatures, radiation, vacuum, and long autonomous operations with communication delays. We need robust drilling, energy-efficient extraction, and systems that self-repair or operate flawlessly for years, from the smallest bolt to the main power system. There are no rescue missions out there. Legally, the 1967 Outer Space Treaty forbids national appropriation, but is vague on private resource rights. We need international rules for who can mine, site allocations, and how benefits are shared. Responsibility matters. Altering an asteroid's orbit must be done with extreme care, and some bodies hold unique scientific value we must preserve. The journey tests our wisdom as much as our engineering. The future is bright, but we must move forward with both ambition and caution. Beyond our blue marble lies a treasure chest and a test of character. Space mining could redefine what's possible for Earth and for generations to come.